Welcome, everyone, to Manufacturing Talk Radio with my buddy and co-host, Tim Grady. He's been with me a little shorter than the time that I've spent with my wife. I think it's 25, 27 years.
Less than 30.
Yeah, it's less than 30. My marriage is going to be 34 in another month. Second marriage. We have here today Artem Kroupenev. Correct me. Go ahead.
It's Artem Kroupenev.
Kroupenev. I
That's
left
right.
out that accent. Kroupenev, who is with a company called Augury. And I got one. I'm one for one. And it's we're going to be discussing AI today and all that relates to Augury's company. And you've got the floor.
No, great. Well, thanks so much for having me. And great to meet both of you. Absolutely.
So tell us about Augury.
Sure. So Augury is a leader in the industrial AI space, particularly in the machine health and process health space. We provide a capability that integrates artificial intelligence technology, IoT, and puts that power into the hands of professionals within the manufacturing world. Machine health, it enables reliability engineers and maintenance people to essentially predict when machine failures are going to happen and avoid unnecessarily downtime, increase the performance of that equipment, and also enable them to basically run their operations smoothly and focus on more strategic tasks as a result. And process health is an AI-based optimization technology for production processes that's geared towards process engineers and operators. And it enables those people and those functions essentially do a very similar thing for production processes, meaning if they want to optimize for better quality, throughput, yield, sustainability, and do that at the same time, process health algorithms help them understand what is the best and optimal settings, what's the center line for the production process to meet those production objectives, and it does that autonomously. And today, Augury does both, and our goal is to, over time, integrate those into something that's more akin to an AI-driven co-pilot or an operating system for the full factory, and that's where we're moving towards. We work with over 100, some of the largest manufacturing companies in the world, primarily within the continuous process manufacturing, packaged goods, paper, building materials, chemicals, petrochemicals, pharmaceuticals, and others, so critical goods that we all need. And we help those companies unlock production capacity, produce more effectively, more sustainably, while at the same time not having to replace or significantly change their equipment, their existing production processes. So kind of seamlessly integrating the power of artificial intelligence into the production process, into the reliability maintenance processes. So that's who we are and what we do in a nutshell.
How does AI, speaking generally, how does AI affect or not affect the workforce, either today or going forward? And that's only part one of my question. So I'll let you handle that first, and I'll ask you the second part.
Absolutely. I think like any major leap in technology, in the end, I believe that AI benefits humanity and benefits the workforce. But with that, when you have something that is as powerful or can provide capabilities as powerful as AI, the workforce will need to adjust, right? And really, it's in the details of how you approach that adjustment, right? So you have a new set of capabilities that requires a different perspective, a different way of working, a different skill set. How do we make sure that we empower the workforce and people to utilize those capabilities, those technologies, and make sure they get the necessary training, the necessary concepts, capabilities to be able to adopt it as quickly as possibly. And to do that in a way that is mindful of the current ways of doing things and the practices and kind of the legacy systems that we have in place. I think that's one of the bigger challenges with the workforce. But the net effect of AI on the workforce, and especially the workforce in manufacturing, is going to be a significant upgrade in terms of the ability to make better decisions, to do things faster, more effectively. And ultimately, what we will see, and I hope we will see, is something that is very similar to what happened to software engineering over the years. With software engineering, you had a very linear way of working. You did one thing after the other, and you kind of planned these big projects, and you had a small team of experts that knew everything end to end, that were only able to do that in a kind of a waterfall manner. But over time, as we kind of democratized access, enabled more access to software engineering, made the languages simpler, made the development tools more accessible, you had more and more people come into that field, and it grew exponentially, right? So you have a lot more people who are in that field today than there were 20 years ago. It's a lot more accessible for a lot more people.
But excuse me, but a few moments ago, you said that change is the challenge. And we all know how people love making changes. So has there been resistance? Will there continue to be resistance if there is resistance?
Yeah, so just to continue my thought, because I started that analogy with software engineering, the reason it became a lot more ubiquitous and available, and a lot more people entered that field, is because it became simpler. And we've created tools that and processes that enabled a lot more people to kind of develop the skill set that's necessary for it, because it became simpler and easier to use. Mm-hmm. And this is a very similar process that will happen in manufacturing, right? There's always resistance to change, and especially if it's generational, right? We're used to working a certain way, and also the nature of the way we do engineering and manufacturing, right? If it's not broken, you don't fix it, right? You just keep it going, right? That's really the approach today. So really, it has to be driven by how simple and easy it is to understand, how available and accessible the technology is to people, and at the same time, clearly help people understand the benefits of what it can provide them in their roles today, right? And so those are the two forces that I believe will help people change and transition faster than they would otherwise.
Tim, I've kind of taken over here. Why don't you get in the middle before I can get to my second part of my question?
Artem, we're glad you're with us. About two and a half years ago, we interviewed Lorana Kavia of SIBO, mm-hmm. and you and SIBO have joined forces. Can you explain to our listeners and viewers what's happening between Augury and SIBO? And I know you've got, between the two of you, a lot of major manufacturers using artificial intelligence with guaranteed results that you'll be able to tell them what's going to go wrong before it does go wrong.
That's correct. So Augury acquired SIBO last year, 2022. The company was about 85, 90 people, and they joined Augury's team. For us, it was fairly straightforward in terms of the strategy. Why would we join forces with SIBO and acquire that company? And we kind of established a leadership within the machine health space, addressing reliability and the health of equipment. But our customers, as we have started to deploy at scale, whether those are leaders within the manufacturing area or engineering area or reliability, have started asking us, well, what else can you do? How can we expand this? And so the next frontier was pretty clear for us. And the frontier for us was moving from the performance of equipment to the performance of the factory itself, or the production processes. And we made decisions around, should we build this ourselves, or should we look for companies, to join forces with, that have already established the technology in this space that we can utilize and provide and expand towards our customers. And Cibo had those capabilities and had the right vision, and also had a lot of overlap with our customers in terms of who we're addressing. So it was a pretty good match, and a seamless match, if you will, and a lot of the culture in terms of how we approach this world of manufacturing and our customers is very similar. So Augury, with machine health, we solve not just for a specific use case or a tool set, we solve for a function, right? How can we make sure that we integrate those technologies like AI and IoT into the realm of reliability engineering and make that function significantly better, right? From a very human-centric, human-first approach. How do we make reliability engineers, maintenance people significantly better, like they have superpowers, right? That was our mission. Cibo has the same approach to process engineers, a deep understanding of the domain, a deep understanding of who process engineers are, what their challenges are, what they need, what do they need to achieve, and essentially providing a technology that they can eliminate weeks and months from process engineering work. But the outcome to the company that produces, to the manufacturer, the overall outcome is very similar, right? You optimize, you help them become a lot more agile, a lot more resilient, a lot more sustainable. So that was the match between us and Cibo. And it's the combined value proposition resonates across all of our customers. So we've had a significant demand and a very favorable, I would say, sentiment from our customers, because they say this is exactly what we were asking for. That's and you guys are doing the right thing.
Oh, good. Lou?
Part 2.
Yes.
AI in its most basic form is complex, certainly for people who have no knowledge, even those who are in manufacturing. And there's no real good information out there about how it evolved and what is it, and so on and so forth. And I'm sure you know the individual, or know of the individual I'm going to talk about for a moment, and that's James Barrett. You know the name James Barrett? He's the author of The Final Invention.
Mm-hmm.
And the whole book, obviously, is about AI, from the beginning to the end, where they're talking about AI as the final invention, meaning at some point we might not need people in manufacturing. And I think one of the things that scared the hell out of me was that they talk about, in one particular point in the book, about the fear of what happens when the machine knows how to turn itself on and off.
Mm-hmm.
Like in the movie Space Odyssey, mm-hmm. the computer, whose name escapes me for the moment.
HAL 4000.
HAL, right? That's
Mm-hmm.
HAL. The 3 letters right next to IBM, and HAL was an evil computer. Is there a possibility that the programmers who do the programming for A1, if they slip something into these software, hardware, that some of these machines may go rogue? That's the question.
Good second part of the question. So let's break it down a bit into a couple of things. First of all, every major leap in technology, or every major technology, has the potential to do good and potential for flaws, right? What's I think good about the space that we're in manufacturing is that the majority of the people in manufacturing are technical, and also a lot of us are engineers, right?
Right.
So as people who are on the technical side of things, who like to build things, who understand how things work, we need to go a level deeper into actually understanding how something works in order to then make an educated opinion on what is the risk that's associated with that technology and what's the benefit, right? I'll give you an example. If you take film or movies in the early in the 1920s or 30s, right? I'm sure people saw a train coming at them from the movie screen for the first time in a movie theater, and then said, "Oh, this is devil's work, and we don't know what's real anymore," and tried to burn down the theater. The same thing happened with electricity, right? And they electrified elephants to show how dangerous DC current is, and so forth. There's a lot of apprehension about what does it mean for us, what does it mean for our jobs, what does it mean for our lives, and so forth, right? And yes, there are major technologies that could be weaponized, right? And so that is why society, and I'm not saying just people who develop the technology like Augury, but society in general, across all the different walks of life in society, have to have a hand in devising the new rule set of values, of morals, of ethics, of how do we deal with a leap of technology. And that's an ongoing conversation. So the concerns or the fears are valid, but they have to be taken into as an input into the ethics of how we will deal with the outcomes of the AI, the same way that we dealt with the outcomes of electrification, the same way that we dealt with the outcomes of nuclear energy and power, and so forth, right? So I think that's the bigger question. But for us, for kind of people who are in the details of implementing it and building that technology, I think we need to focus on, first of all, understanding what it is and how it works, right?
For sure.
And helping others understand, right, how it works, so that the irrational fears can be separated from what's actual and what's real, what's rational. And in a nutshell, if you think about the application of AI technology versus, let's say, electrification is an extension, in a way, of our body, of our limbs, of the mechanics, right? How do you power machines, and how do you communicate across long distances with a lot more power, a lot more capabilities? AI is different in the sense that it is, in many ways, an extension of different functions of our brain, right? And so not yet to the extent where it actually can make decisions of its own, right? Or dream up all kinds of things that Hal, the fictional character Hal 4000, could. But we need to look at it as, what is the benefit of extending certain parts of our functions in our brain, right? How do we process images or see much better? How do we make sure that we can communicate at a much better, higher level, right? How can we devise solutions to problems in a much faster way? And this is where kind of the first generation of AI, if you will, this is where that's been very helpful. So you have kind of the first generation of AI, I would say, is the decision support tool, in a way, in the way it kind of enables us to tackle certain use cases, where it's much better or faster at analyzing and detecting patterns in data and information than we could ever do. And then it helps us with insight into certain things, right? Is this machine failing, right? Or these 100,000 machines, when are they going to fail? How are they failing exactly? What's the best way to optimize my process? What is the best way for me to understand what are the best results to a search query on the internet, like Google? What is the best way for me to summarize tons of data so I can get a certain type of insight that I'm asking for? That's kind of a more domain specific AI. That's the first generation. The next generation of AI, and we can talk about that if you'd like, can actually generate new content, right? not just help us process information a lot faster to get to a level of insight, but they can actually start helping us generating new content and conversation and coming up with answers that did not exist before. So that's a better way of analyzing patterns. But that I would say that is not AI that can think for itself. It's just a much better tool for us to become smarter and make better decisions.
Artem, what I would like to do, and we don't do this too often, I'd like to hear the rest of the story on part 2 of
Sounds
our
good.
show with you. Because I think from what little I know, it might be conceivable that these machines may be able to think for themselves at some decades into the future.
Potentially, yeah.
There you go. He said it. He said it. He believes it. Okay, Artem, this was great. I really like it. I appreciate the fact that you dumbed up the story so that some people have a better understanding about the benefits of not necessarily knowing all the algorithms and this, that, and the other thing, but where the real benefit is. And I really appreciate that. And I would like to do a second part with you about the future of AI. Tim?
Yeah, it's been really helpful, and we appreciate you being on with us. And I'm sorry that we don't have more time, because I know when we talked with Shivo in episode 644, and again, speaking with you, that there are some significant savings here that shorten the ROI on implementing AI into manufacturers that really need to be looked at. So I encourage people to go to augury.com, AUGURY.com, and get a hold of Artem to learn more about that. Artem, thanks for being with us. We appreciate your time.
Absolutely. Yeah. Looking forward to the next episode. Thanks so much.
We'll be in touch and we'll set it up. Thank you very much.
And thank you, everyone, for tuning into this episode of Manufacturing Talk Radio. And you can check us out at our website, which is jacketmediaco.com, although that's beginning to change. But check out our channel on YouTube. And thanks again for being with us.
Thank you all.